Let us look at proposition number 6 of works of Archimedes, specifically from on the conoids and spheroids. The proposition says the areas of ellipses are as the rectangle under their axis. So let's see how we can prove that the areas of these two ellipses are in the same ratio as the rectangles under their axis. So let's begin. Given two ellipses Q1 and Q2 with A prime and BB prime as the major and minor axis of Q1 and MJ and LK as the major and minor axis of the ellipse Q2, construct a rectangle on A prime with B prime C as the height. Let's mark these points as E and F. Similarly, let's draw the rectangle under MJ and let's name these as N and O. Construct a rectangle on MJ with IK as the height. Here, this point is I. Draw the auxiliary circles to both Q1 and Q2. Let's draw the circles, auxiliary circles. Q1, the ellipse, is to the circle Q1 auxiliary is equal to BB prime is to A prime. We have seen in the previous propositions that the ellipse has a ratio with the auxiliary circle as a minor axis has to the major axis. Now multiplying both the antecedent and the consequent by A prime, we get A prime times BB prime is to A prime square. Similarly, for the other, Q2 is to circle Q2 ox is equal to KL is to MJ. Again, multiplying the antecedent and the consequent by MJ, we get MJ times KL is to MJ square. And we know that these two auxiliary circles are to each other as the squares on their diameters. So that means A prime square is to MJ square. Now let's build this proportionality. Q1 is to Q1 ox is to Q2 is to Q2 ox is equal to A prime times BB prime is to A prime square is to MJ times KL is to MJ square. And X equally we can see that Q1 is to Q2 is equal to A prime times BB prime is to MJ times KL. Now again, we divide the ratio on the right hand side, both the consequent and the antecedent by 2. So A prime times B prime by 2 is to MJ times KL by 2. And here what we are going to do is we are going to divide BB prime by 2 and LK by 2, which would give us Q1 is to Q2 is equal to A prime times half of BB prime is CB prime is to MJ times IK, because IK is half of LK, which is equal to, now we can substitute CB prime with AE because they are equal. Similarly, we can substitute IK with MN because they are equal. So we have Q1 is to Q2 is equal to A prime times AE is to MJ times MN. And these are rectangles that we have drawn. A prime times AE and MJ times MN, which is what we had to prove. There is a corollary to this proposition. It says the areas of similar ellipses are as the squares of corresponding axes. So, which means we need to draw a square and a square. And these squares will have the same ratio as the areas of these ellipses only if these ellipses are similar. Now, what does similarity of ellipses mean? It means that the ratio of the major axis to the minor axis of one ellipse is equal to the ratio of the major axis to the minor axis in the other ellipse. If that is the case, then Q1 is to Q2 is equal to A prime square is to MJ square, and we could also look at it in terms of the minor axis. Q1 is to Q2 is equal to BB prime square is to LK square. So that is proposition number 6 of works of Archimedes, specifically from on the conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.